Now the other thing that I want to do now, right, is to write a program, okay, that is going to sort of do find the string length for us, okay. Char star p test equals okay. So what I can do is maybe I can comment out this entire block. Okay, I'll comment out this entire block now, and I will only deal with this new code that I want to write here. So what I'll do first is, of course, so we are going to go through this program in a little more detail, because we'll first use string length to calculate the length of the string, right? Then we'll write this code in C, okay, and then we will go to the assembly implementation of the same thing, okay. So int len equal to strlen p test. So str equal to %s, length equal to %d, p test, and okay. So let's see what we get here. I hope this compiles. It says something here. Oh, this is, it expects a C++ compiler. So okay, so we cannot use the string length thing. So what we'll do is we'll go ahead and write this code in C. Okay, so how do you write this whole thing? Int len equal to 0. Okay, and then I'm going to say int I equal to 0. Okay, I'm going to use a counter. Okay, p test of I not equal to, what is this, \0, right, because len plus plus and then I plus plus, right. Of course, I could just, we can optimize this code a little later, but we'll just do this whole thing and see what we get. Okay, so I will remove all this string.h and all that. Unexpected end of file found. Where is this? So this should be okay. Okay, maybe this code is what is causing the problem, so I will remove this. Right, so it says the length of this string, this is a test string, so it is 4 plus 2 plus 1, 7 plus 4, 11, 11 plus 6, 17 plus 1, 2, 3, 4 and 4 spaces, therefore the length is 21. Okay, so this is very very simple kind of a program that we have written, right, and so you can, of course, you can write this in many ways. You can even perhaps do away with this variable, right. So all we have to do is use len itself here. okay, while p test of len not equal to backslash 0, you keep doing len plus plus, eventually you come out of the loop when you hit the backslash 0, right. So this is exactly the string length program that we wanted to work with, okay. So now what we'll do is just like in the multiply example, we are going to go ahead and comment this whole thing out, okay, and write the same piece of code in assembly language. So what do I need to do now? I basically need to start with the pointer's address, right. So the character array, okay, if you look at this, so let me come back to this, okay. So I have p test equal to, this is a test string, okay. So if you look at what is going to happen, p test is basically a pointer, right, or it's a pointer to a character array, okay. So if you look at this particular memory, okay, if you look at the picture of the memory here, somewhere in the data segment, right, each rectangle now being a byte of information, my p test will be pointing to this location. Here you will have the ASCII value of t, then you will have h, I, s, then you will have a space, okay. So you will have an ASCII for space, okay, I will write that explicitly, ASCII for space, okay. Then you will have I, S, like that it will go on, eventually you will hit string G, right, and then you will hit 0x000, okay, 0x00, because it's a byte, okay, not 32 bits, right. So if you look at the memory picture of this particular character array, it is exactly going to be here, right. So what you are even doing in this case was to simply look at, p test of I, p test of I plus 1, I plus 2 and so on, right. So that's what we did. So in fact, maybe before we go into the assembly implementation, let us look at just this pointer arithmetic of this character array also. Alright, so I'll say char star PA equal to P test, okay. I am going to just point this PA to P test itself, and what I will do, I will say star PA not equal to backslash 0, len plus plus, and then PA plus plus, right. So let's wait for this to compile and then we'll see what the answer is. The only difference here is, instead of accessing the array elements as p test of I am now starting with PA and then going up PA plus plus, right. So PA plus plus is now a pointer arithmetic. It is incrementing the pointer to a character array by 1 and it will make it point to the next character location. Where is that character location? The size of a character in C is 1 byte, and therefore the next byte will be in the next character will be in the next byte in the memory, okay. And that's exactly what you saw here. So it will start with some particular address, some 0x FA FFAA something, FFAA BBC 0. Then this will be 0x FFAA BBC1, right, and so on. And this \0 will be basically after all the 21 characters. In the 22nd location you will see this particular thing, right. So that this is an alternate way of writing the same program. Now please note that when I am doing this while loop, okay, I can do this in any particular order. I can do len plus plus first and then PA plus plus, or I could do PA plus plus and then len plus plus. You will still get exactly the same answer. Okay, but later I will show you in assembly, you must be very careful about this order, okay, because the jump instructions react to a flag register which is set by the most recent arithmetic or logical operation, okay. So keep that in mind. I will come back to this at a later point. Now let's return to our assembly implementation of exactly the same idea, right. So I'm going to do move EAX comma P test, right. So EAX now has the address of the character array, whatever this P test was a pointer, right. So it's going to get an address, okay. Now what do? I am going to move, I will clear my counter XOR EBX comma EBX, okay. So what I am going to do now is I am going to check for the \0 thing and then increment things appropriately. So what will I do? I will do a compare of EAX comma I am going to say byte pointer, okay. We will see if this works. I don't know if this will work. I might need to use a register. Well, this seems to work. So we will see this thing, or for now let me maybe use the register also, right. I will say CL equal to CL comma 0x00, okay, CL. I am going to compare byte pointer of EAX with CL, okay, and if it is not equal, if it is not equal to \0, then what do I need to do? I need to go ahead and increment my pointer to point to the next character array and also increment my count, okay. So I will give this label called compare, right. I am going to call this compare and I will say jump on no 0, okay. That means it is not equal, right, which means that the compare will not set the 0 flag to increment INCR, okay. So I will explain this program a little later. If it is not true, then I will do so I am going to do this right. Okay, so we will see why I am doing all this, okay, done. So if I am done, it means the answer, right, of the string length is now in EBX. So therefore I will simply do move E into the variable len, I will move EBX, okay, and then I will just come out of my loop. Now if it is, of course, so jump on 0 means the compare is exact, that means you have hit \0, you are done, you come out. Now if it is not 0, then I need to do the increment of EAX and increment of EBX, right? And after this, I will unconditionally jump back to compare. So let us see if this works now correctly. Okay, so magic, you see here the string length comes out to be exactly 21. Okay, so now let me explain this code to you a little bit. So what I did was I am comparing now byte pointer of EAX. Why byte pointer? Because this is a character array. If the size of the character was not equal to 8 bits or 1 byte, then I cannot do byte pointer. Okay, I know that the character array in C is stored as an array of bytes. That is, the character array is stored in consecutive bytes. Okay, and therefore I can do compare byte pointer of contents of EAX. Now what is contents of EAX? It is the address pointed to by EAX. Okay, so initially I have pointed it to the address of the value of p-test, the pointer p-test. So whatever that address is, I have initialized to that, and then I am comparing with CL, which is 0x00. That's the character I am looking for in that particular, I am looking for that particular pattern in that array to stop my string length operation, right? So I compare, and then if I compare and I find it is 0, then I need to jump on 0 to done. Okay. After that, I am going to say increment EAX, right? Why? Because if the code came here and found that the 0 flag was set, it will simply jump to this done, and then it will be done, it will finish the program. Okay. Now what I am doing here, I am saying increment EAX. That is, if the 0x00 has not been encountered, you point to the next character, you increment the count by 1. That means string length is at least 1 now, right? You increment, and then unconditionally I am jumping back to that COMP location, which is going to now compare the next character with the 0x00 that is stored in CL, right? So when I come out of this, you are done with this whole thing, and you have got the answer in the length variable, and the answer is printed here to be exactly equal to 21. Okay. So therefore, remember here once more, like I told you in the C code, it is okay to interchange the order of this PA++, len++, all these things don't matter. But here, it's okay to swap these two. You can swap this increment EAX, increment EBX, but you have to be very careful about where you put these conditional jumps, because the compare operator is now going to set the flag, and based on that flag you want to jump. Okay. So if you do this increment operation, right? So for example, let me just show you this. This is not going to be valid. Okay. So you see some very arbitrary output and stuff, because we have messed up the location of this jump. So if you look at it, what have we said? We have compared byte pointer of EAX with CL, incremented AAX, incremented EBX, and this thing. Now the problem is, this increment operation is going to go and set the flag, and therefore it has overwritten what this compare operation is trying to do. Okay, and therefore jumping on 0 here makes absolutely no sense. So that's why this is very, very critical, and this order is the most critical thing that you have to get used to in assembly programming, right? So now when I put that back and maintain the order correctly, the string length comes out to be exactly 21, as we had found earlier in the C code as well.